Alright, so this is just working through T4R4, which is a measurement review activity. And the first question here, we've got a sketch of a school hall, and they're asking us to determine the perimeter of the building. So we need to remember, when we're determining the perimeter of the building, we're just basically adding up all of our sides of the building. So the easiest way to do any perimeter is you start at a point. So let's say I'm going to start in this corner over here, and you kind of walk your way around the shape, but as you walk, you're going to add it. So we're going to start by going this way along, and I'm going to add 17. Then as I keep going, I'm going to say, okay, let me keep walking this way, and that's 15,81, so I'm going to add 15,81. The trick with perimeter is don't get into a formula. So I got up to this point, I'm going to now walk along this side, and this side is 22, so I add 22. Don't get stuck into formulas for perimeter, because perimeter, the easiest thing is just to walk your way around the shape. And then the last one going up here, which is 15, so I'm just going to say plus 15, and then you're going to add them all together. Which we have 69,81. And because we're doing calculations, we always put in the units, so we're going to say meters, and that's the perimeter. Okay. The second question asks us there, some learners will be performing music and dance items. They need to know the area of the stage, and they tell us the dimensions of the stage are 11 by 5,5. We have here 11 and 5,5 meters. They want us to calculate the area. So if I look at my stage, I'm going to just fill in my measurements. It's a good habit to get this, because you don't know when what else they're going to need you to use those measurements for. So to have it there, and that's a rectangle, and you would be given formula for a rectangle is length times breadth. So we're just going to say area is 11, which is our length, times by our breadth is 5,5. Okay, and when we do that, 11 times 5.5, we get to 60,5. And our unit should be now in meters squared, because its units are meters and area, so we square the units. The last question asks us to calculate the total area of the hall and the foyer. So I'm just going to clear my page, so I've got some space, and they want us to do the whole area of the hall and the foyer. So this is a complex shape because it's got more than one of our base shapes. So the important thing you need to remember is, for area, we know how to do circles, we know how to do triangles, we know how to do rectangles, and squares, but squares are a type of a rectangle. So you always want to now divide your shape into those base shapes. Okay, that's the first thing you need to do, is cut up your shapes. So if I do that over here, let's do it this way here, that's going to be my cutoff point. So we're going to do those shapes separately. This is the big thing with area, we always do our shapes separately. So our first one is our rectangle, and rectangle is length times breadth. And my length of my rectangle is 17. My breadth is 15. So I'm going to go 17 times 15. And if you work that out with your calculator, you will get 255 meters squared. Now some people will be saying, but why did I use the 15 the 17 and not the 22 at the bottom? And that's kind of because if you look at where the cutoff point of that shape is over there, right? This 22 goes past my cutoff point over there, and I don't want to include the section that's not part of my rectangle on the end there. So I don't want to use a measurement that includes parts that are not in the shape I'm calculating. Then I'm going to look at the triangle, and the triangle here, if I look at the triangle, it's over there, and the question now is, which measurements do I use for that? So triangles, we know to find our half base times perpendicular height. That's always the measurements we're going to look at. And if I look at this triangle, I need to identify which side is going to be the base and which side is going to be the perpendicular height. Now remember, perpendicular height, we're looking for that T shape that's going to form. And in this case, so we can see it there, that T shape is being formed with these two sides of my triangle. So those are the two sides that I want to use. I don't want to use this 15,18 because this 15,18 over there, that side does not form a T with any other side. It's not forming a perpendicular height. So I'm not going to use that one. But then the question is, well, how high is my triangle? And the triangle height is 15. So I'm going to carry that 15 all the way across. And say it's 15. And then this base, the question is, how long is the base of the triangle, right? Well, we're going to have to use this 22 because, oops, it's 22 because it's got to do with the base. It's the only thing I know. But the 22 is the full way along. So the thing to recognize here is I already know if I cut it at the triangle point, this rectangular part is 17. And the question is 17 plus what gives me 22 altogether. And it's 17 plus 5 gives me 22. So my base for my triangle is 5. So therefore I'm going to go half times base, which was 5, times 15, right? The 15 coming across from the other side. And if you do that, you will get to 37,5 meters squared. So now I have my triangle, I have my rectangle there and there, and to get the total shape we're just going to put it all together because we want total. So we can then say, and I'll just do it over here, total area is 2255 plus 37,5, and when you add those together you're going to get to 292,5 meters squared. And that's the answer for number 3. Alright, question 2. Kingstown Secondary School plans to rehabilitate their cricket pitch for winter sports season. They've given us a diagram below of the cricket grounds, with the outfield being the circular part, the rectangular pitch in the middle. So, first question they ask us is define the term perimeter. Now, this question does not say in context, it just says define the term perimeter. So, we can just do this as a general definition. Perimeter is the total length of the outside of a shape, or of the boundary of a shape. So we're going to say length of boundary. Oops. Okay, length of boundary. The important thing when we're defining perimeter is we're wanting to be talking about length, because that is related to the definition of perimeter. Okay. If they had said define the term perimeter in context, then you must say total length of the boundary of the cricket grounds. Okay, then you must reference cricket grounds if they said in context. But this time they didn't, so you don't need to do that. Then they want the perimeter of the pitch, and they tell us there's a formula there. Now, because the pitch is straightforward, and just a note, the pitch here is the rectangular section, and we know that because they tell us here this is the rectangular pitch. So they really just want you to know what is the total length of the outside of our pitch over there, like that. So we can just use a formula because we've been given the formula, and we can get the information from the side information over there. So the perimeter, we just write it in there, make it a little bigger. 2, length is 22,56 plus breadth 3,05, and you can pop it into a calculator just like that. It gives us 51,22. So 51,22 comma 22. Now because we're dealing with perimeter, our measurements are in meters, so we just say meters. We're not going to say meter squared because it's not area. Right, the next question asks us there that the school decided to use an artificial pitch, which is overlaid queen mat on top of the cricket pitch. They want to know the area of the mat pitch to be bought in square meters. So this is only dealing with the pitch. So again, we're only dealing with that rectangular section. And they give us our formula. So this time we're just going to use our formula and fill in the measurements. So we're going to say area is equal to our length of 22,56 times by 3,05. And if we do that, we're going to get to an answer of 68,808. So 68,808 meters squared because it's area. And then they tell us there, yeah, that's all that they're needing is the area of the mat pitch to be bought. So that's the area. Right, question 2.4 asks us to calculate the area to be grassed on the outfield pitch in square meters. So now this is talking about the outfield in square meters. So the section that's going to be grassed is basically the shaded section, right? If I can get this in a different color here. So it's basically this whole shaded section over here is going to be the area that's going to be grassed. So what we're going to need to do is we're going to need to work out what is the area of the whole circle going around as if it was a solid circle. Okay, so you always want to start with saying, I don't care about the stuff that I'm excluding. I'm going to pretend that I'm doing everything first. Once we know what that area is, we can then say, okay, let's cut out and let's subtract, meaning remove, the sections we don't want. And in this case, it would be the pitch. So let's start with just working out the area of the outfield. Now they do give us a formula in the question, but I'm just going to do it up here. So the area of a circle, they tell us is pi radius squared. And we just fill in the information we know. So we know that pi is 3,142. That's the value you're going to use in Mathslit. Our radius of our circle now, they tell us over here, just be careful that we're given radius and not diameter. In this case we are, so it's 68,75. Okay, let's move this over a little bit. Okay. And then we get our answer by putting that into, oops, I've left out the square. The square is very important. A lot of people miss out that you do need to square your actual measurement. So please be careful that you don't miss it. And then we're going to put it into our calculator. 3.142 times 68.75 squared. So the calculator does show the squared. And I get 14,850. 14,850. Comma 8593. 85,938. That's the whole length. Okay. Now that would have been a solid circle. I now need to take from that and subtract the area of the rectangular pitch because we know that's not being grassed. That's going to be done with the coin mat from the previous question. And so we're going to go here and say, right, area of the circular area minusing the rectangle. You don't have to show that, but I like to show what I'm doing at each stage. So 14,850, 85,938 minus my previous answer of 68,808. And if I do that, I get to 14,782, 05. 138 if I'm going to do the whole decimal. 138. And this is meters squared because it's the area that needs to be grasped. on the outfield. Okay. The last question there on this is the total circumference of the school ground is measured as 500 meters around the field. Is measured to be 500 meters around the field. Determine the cost of the rope if it was 50 meter rolls at 110 rand each. Okay, so this one I don't actually need to see my diagram for because they're giving me the circumference of the cricket ground, so I don't have to calculate it. I just need to now work out the costs. So it's 500 meters in total, and we can do this as a ratio, and we do it as a ratio by going and seeing, okay, well, it's 110 for 50 meters. I need for 500 meters. Now, some people like to go and say, okay, well, listen, I can already see that this is just multiplying by 10. 10 times as much, I can multiply by 10. That works perfectly well if that is the way you think about it. I know I teach my students we're going to do divide up, multiply across. So I go 500 divided by 50 and then multiply by 110. That will also work. There's a few different ways you can kind of think your way through it. I always go, as soon as you see there's a relationship, like there's a cost, it's always a cost for a quantity. That is a ratio. So write it as a ratio. Divide up, multiply across. We're going to get to 1,100 Rand for our cost. And that's your answer. Okay, let's look at the last question. Right, this one has to do with Simma's mother who decides to renovate her room, and the tiles in the bedroom bathroom need to be replaced. The following sketch is a two-dimensional diagram of her rectangular bedroom and her semicircular bathroom. The semicircle has a radius of 1,4 meters, and they do tell us the diagram's not to scale. So the only reason for telling us that is just so that we know not to worry if like it looks like the one should be smaller or bigger than the other. We're just going to work with our measurements. Okay. So the first thing I want is the dimensions, the length and the breadth of the bedroom. So if we look at our diagram, our bedroom is here. Okay. And our length we can see pretty easily. I mean, our width is pretty easy because it's right there. It's 2,6. The question now is how long is the bedroom? Well, this comes from that idea that we did in the previous question of going, look, I know this first part, right? I know from here to here is actually 1,4. because it tells me that. So the question then is 1,4 plus what gives me 4,2, which is the full length. So I'm going to say 4,2 minus 1,4 gives me 2,8 meters. So it's going to be 2,8. So as soon as you see the word dimensions, dimensions just means you're going to tell us the length separately. The length 2,8 meters. And you're going to tell us the width separately, which is 2,6 meters. That's all you have to do. You don't need to multiply, you don't need to divide, you just need to state the values. Okay. Next thing they ask us is to work out the area of the following rooms. So the first one being the bedroom. So a bedroom they tell us there is length times breadth. I'm just going to put down our measurement for our bedroom. So bedroom, we're going to go length times breadth. My breadth properly, which is 2,8 times by 2,6, and that will give me 7,28 meters squared. Okay. Then they want us to do the bathroom, and they've been nice in giving us the area, the formula for the semicircle, not even for a circle. And we know it's a semicircle because of the half over there. So we're just going to substitute it in. I think I'll do it on the side here just for the sake of space. So I'm going to do it over there, the semicircle. We're told is half times pi times radius squared. So we're going to say a half, because a half is a half. Pi is 3,142, and my radius is 1,4, and I must square that. It's going off the screen there. And if you do that at that point, you can put it into your calculator like that. And I get to 3,07916 meters squared. Then they want us to work out the total space. Well, the total space is just going to be adding the two together. So we're going to take our area of our bedroom and our area of our semicircle, and we're just going to add them together. So I'm going to go 7,28 plus 3,07916. When you add those together, you're going to get to 10,35916 meters squared. Okay. They do tell us they want us to round to 2 decimal places, which actually should have done that in the previous question as well. So if I'm going to round, let's just go back a step here, because they told us over there in the question to round it. The previous question would have been 3,08, right, going up because of the 9. And this question would have been 10,36 with the rounded value. Okay. By the way, you don't have to use the unrounded value here. We could have gone to say that 3,8 and left off that, because it carries your answer from a previous question as well. Okay, last question. Simba's mother intends to tile the bedroom and bathroom with tiles that are 40 centimeters by 40 centimeters. How many tiles should she purchase? Okay, so this one comes from the idea of going, okay, we need to understand, I know the area of what she wants to tile. I can work out the area of each tile, so I can work out how much space the tile covers, and then I can work out how many tiles for the whole area altogether. Now we do have a small issue though, because if I look at this measurement, these are in centimeters over here, and my measurements for the area are in meters. So I need to convert. It's always easier to convert first. So you want to be converting before you actually calculate. Converting after you calculate changes a little bit, and it's going to make it a bit more complicated. So I'm going to convert first, and that means it's 0,4 meters per tile. And then we know a tile, if it's 40 by 40, that means it's square. So the area is going to be 40 times 40, or 0,4 times 0,4. And that gives me 0,16. So it's 0,16 meters squared per tile. Now, if you think practically, what we're doing when we're dealing with tiles fitting into a space, we're actually breaking that space up into tile shapes. We're splitting it into these little square tile pieces. So whenever we're breaking something up into smaller sections, we are wanting to be thinking about dividing. So let me just get a little bit of space over here so we can divide. So what I'm going to do is take the area of my bedroom, so the area of the bedroom, which was 10,36, right, meters squared, and I'm going to divide it by 0,16 meters squared by the tile. And if I do that, and I go 10,36 divided by 0,16, I get to 64,75. Now the important thing here is my answer. What was I looking for? I was looking for the number of tiles. So this is tiles, not meters squared, because I was looking for the number of tiles. And how many should she purchase? So the question says, how many should she purchase? Well, she can't purchase a part of a tile, so we must round that up, not down, or she'll be short. So she must purchase 65 tiles. Okay, we're always going to round up for purchasing building supplies, otherwise they're going to be short. She can then cut that 65th tile to fill that gap of 0,75. Okay, that was the end of that activity. Hopefully if you found that helpful. If you're still not sure about why something was done the way it was done, please chat to your maths lit teacher.